Okay, so today, brand new chapter, quadratics. We ready? Okay. Quadratics. Today we're starting a brand new chapter. I do quadratics second chapter because you guys did quadratics in math 2. But you didn't do these things on the board. Okay? So that's where we're going to pick it up. So half of this will make sense, or half of this you'll remember from last year, half of it you might not. You probably won't unless you've been in math 3 before. Okay, so the first thing. What is a quadratic? I don't feel like I have everyone's focus up here. Okay, now I do. Okay, so first of all, what is a quadratic? Quadratic means there's only one variable, and the degree is 2. Okay, so what is the degree? Degree is the exponent power, the biggest power. So let me give you an example. Did I ask you to tape in right now? I asked you to do this. Okay, put the tape. I got plenty of tape. When it's time to tape.
No, I'm just saying that there's no more tape.
When it's time to tape, I'll give you plenty of tape. Okay? So here we go. X squared plus 4x minus 2. That's a quadratic. Next quadratic. 3a squared minus 4a plus 6. That's a quadratic. Both of those guys are quadratic. Why are they quadratics? Because what is the biggest exponent? What is the biggest power, the highest power? 2. Quadratic. And there's only x's here, right? The trinomial. And there's only a's here. It's not like I'm switching up letters, right? Okay. Next one is cubic. Cubic's the same thing, except the biggest power is 3. So let me give you an example. Square, let's see, minus 2x plus 10. There's one example. Let me give you a smaller example. I use x a lot, but you can use any letter. This guy, the biggest power is 3. That's why it's a cubic. What do you think the biggest power is going to be for a quartic? 4. So let's write something with x to the 4th power. Okay? X to the 4th power. So the middle one is what we're doing today. Next chapter, we'll do the last two, but not this chapter. So the middle one is what we're doing today. So the first two, why did I skip the first two? Because that's what we did last chapter. Last chapter, we did these two guys. Okay, so linear. Linear means power of 1. So let me give you a couple examples. 4x minus 2. Negative 4a plus 6. So in order to be linear, it has to have a power of 1, right? I don't see a powers anywhere, though. Why are these guys linear if there's no powers of 1? These guys had a power of 2, power of 3, power of 4. But why does this guy not have a power of 1? Does anyone know why?
Because power of 1 is not written.
Yeah, it's not written. It's always there, but it's not written. So actually there is a power of 1, we just don't necessarily write it. Okay? All right, so look at the pattern. What will the top one be? What power will the top one be? So how do you write a 0 power? You don't write, doesn't need a variable. Yeah, just whole numbers. Negative 2, positive 6, negative 10, positive 20. None of those aren't J's, those are semicolons. Just to separate them. Okay? Yeah, those aren't J's. Sometimes my semicolons look like J's. Those are whole numbers, right? They don't have any powers, so they're just numbers without variables, no variables. So no variables. Okay? So today we're going to only focus on quadratics. So what does a quadratic look like? Well, it looks like one of two things. It either looks like that, or it looks like that. One is a positive quadratic, arrows up. One is a negative quadratic, arrows down. They look like. They only look like two different things. There's no real variety to it. It's either that one, left one, or right one. So I'm going to show you a picture of the left one. Sure. Its graph is called a parabola. It's got different parts to it. Okay? I know yours is not color-coded. I know yours, but you can kind of look at mine. So when you're talking about the color of the parts. So the red is the parabola. That's the graph. Okay? It's got different parts. The first one is the green line. I have a green line drawn in the middle. That green line is called an axis of symmetry. What does symmetry mean? Anything that's symmetric or symmetrical, what does that mean? Any paper or anything that you folded in half, right? Let me get a paper here. Any paper that you fold in half, and it's the same side. That crease, that's the axis of symmetry. That's the axis of symmetry. Okay? That's that green line right there. It cuts it in half. Everything on the left is the same as everything on the right. You see the two blue dots? Those blue dots are the same distance from the green line. That's always true. Otherwise, it's not an axis of symmetry. Okay, the next thing are the blue dots. The blue dots are where it crosses the x-axis. Those have many names. Sometimes they're called x-intercepts. Sometimes they're called roots. Sometimes they're called solutions. Sometimes they're called zeros. They all mean the same thing. I gave them all to you in your notes because sometimes they call them x-intercepts. Sometimes they say find the roots. Sometimes they say find the zeros. And if they say that on a test, you got all of them. You're like, oh, I know what that is, right? So they're all there. That's all the four names they call it. The other thing is the y-intercept. That's only got one name. That's where it crosses the y-axis. And then the last thing is the vertex. The vertex. If it's a positive, it's going to be the bottom is going to be the vertex. If it's a negative, the top is going to be the vertex, and it's not called a minimum. Here it's a minimum. What do you think it's called if it's up here? Maximum, yeah. The opposite. Okay? Those are the parts. So today what we're doing is we're just going to label the parts. What are the parts? All right? So let's look at, turn it in, or open it up, turn it over, however you have it. Okay? Okay. Vertex. Is the vertex going to be at the top or the bottom for this guy? Bottom. So where is it? Make a dot. Go make a dot. Now we got to tell where that dot is. You got to give address. You got to give the dot's address. How do you get to that dot? You can't just say -3 or -4 because there's two -4s. So if I want to get to that dot, where do I go? So what's the x value? -1, comma, -4. Good. That's the vertex. Is that a minimum or a maximum? Brian, do I have your focus? Okay. So is that a minimum or is that a maximum? Sorry. It's a minimum because it's on the bottom. Minimum bottom, maximum top. So it's not going to have a maximum. So we're going to draw a line there. It's not going to have a max. So what is the minimum? The minimum is always the y value of the vertex. So in this case, it's going to be -4. Okay? Now I got to figure out where that green line is going to be. Where is that green line going to be that's going to cut this guy in half? Well, here's the easy answer. It always goes through the vertex. So it's always going to be a vertical line, and it's always going to go through the vertex. So it's going to be right there. And it always starts x equals. It always starts x equals, because it only involves x. So if it only involves x, which number does it pass through? -1, right? -1. It only passes through -1. It doesn't pass any of the y's. So it's a -1. So x equals -1. Okay? The next one is y-intercept. Where does it cross the y-axis? Right there on my yellow dot. So again, I got to give directions, how to get to that, or it's not yellow, orange dot. How do I get to that orange dot? Can't just say -3, because if you tell me -3, I'm like, oh, over here? That's not it, right? So you got to give me directions on how to get there. So it's 0, -3, 0, -3. The y-intercept always starts with a 0 first, and then you fill in the other one. It always starts with a 0, the y-intercept. Every y-intercept always starts with a 0. Okay, so where are the roots? Where does it cross or touch the x-axis? 2 spots. One is here, and one is here. Okay, so give me directions on those 2. Again, I can't just say -3 because there's also a -3 here. So you're talking about the blue or the orange, right? So I have to give specific directions. So this guy is -3, 0. The other one is 1, 0. So I got to put both of them. Okay. So that's right there is what you did in Math 2. Math 3, we're going to fill in the rest. Okay, you're going to fill in the rest. So I'm going to erase all this because I'm going to need to draw on this guy. First thing that we're going to talk about is something called increasing interval. Increasing, something that's increasing, where is it going? Which way is it going if it's increasing? Up. So in other words, it's saying, where is this guy going up? Where is this guy going up? So you have to tell me where this guy is going up. So yeah, so where the first question you have is where do we start, right? Because up could be one way, but if you're looking at it a different way, it could be going the other. Where do we start? I'm going to tell you where to start. So we're going to start at the left arrow. We call the left arrow -infinity. Why do we call it -infinity? Because it's on the negative side. We call the other arrow positive infinity because it's on the positive side. Okay? So where do we start? We start at -infinity. Start at that arrow. Trace. Am I going uphill or downhill? Downhill, right? I'm going downhill. When do I start going uphill? At that dot, right? So I start going uphill here at the red dot, and then I go uphill the rest of the way, right? Okay, so how do I write that? Well, where did I start going uphill? So yeah, so at the red dot. So I'm not going to use the -4. I'm going to use the x-axis. So when we're talking about increasing, decreasing, we only use the x. So what x number did it start to increase? -1. So I'm going to say from -1 to where? Where does it go to? Positive infinity. So you're going to say, where did it increase? From -1 to positive infinity. Positive because it's never going to stop. Infinity because it's never going to stop. Okay? Now I'm going to put my dot at the starting point, or put my pencil at the starting point again. Starting point is negative infinity. Going downhill, right? That's decreasing. So I start decreasing at negative infinity, and when do I stop decreasing? That same dot, right? Where did we say that dot was? -1. So from negative infinity to -1 is where it's decreasing. Okay? Not too bad. Next one is positive and negative interval. Positive and negative. Positive is where is it above the x-axis. Negative is where is it below the x-axis. So let me highlight the x-axis. Let me draw it a little darker. That's the x-axis, right? Start at negative infinity. Am I above? I call it water. I call this the water line. Like if you're in the pool or in the ocean or something, in a lake, that's the water line. So am I above or below? Above, right? Keep going, keep going, keep going. When do I cross? Okay, so I'm going to highlight this. I was above water here, and then at -3 I went underwater, right? And when did I come up above water again? At +1. Above water again. So the green is where I'm above water. The yellow is where I'm below water. Above is positive infinity, or sorry, positive interval. Below water is negative. Okay? So let's write this down. Green is where I was above. So where did I start above? Negative infinity. And then where did I go underwater? That's our first interval. Negative infinity to -3. And then where did I pop up out of the water again? At 1 to positive infinity. Okay, that was above water, above the x-axis. Now where was I below the x-axis? The yellow, right? So when did I go underwater? -3, and when did I come up? 1. So from -3 to 1. Not too bad. If you know where to start and you know what you're looking for, it's not that bad. Okay? These little notes aren't in your notes, but they help me. So if they help you, you can add them into your notes. You can include anything you want into your notes. It's your notes. Okay? I just put them on the board. They'll be there tomorrow, but eventually I'm going to erase them. Domain. Okay, so how do we do domain? Domain is like this. If I wanted to box that graph in, whoops. If I wanted to box the graph in from the sides, could I do it here or would it bust out the sides? It's going to bust out the sides, right? How wide do I have to go for it eventually not to bust through the sides?
How wide?
How wide would I have to go for it not to go out the sides of my box?
Would you put X?
What? Is it eventually going to go through? Yeah, right? How wide would I have to be? As wide as you can fit, right? As wide, take it easy, take it easy. Okay? As wide as my arms can go, and even wider than that, right? So what do we call that? We call that negative infinity to positive infinity. In other words, there is no cap. There is no, I can't. It's always going to, those arrows would always go through. Okay? The range is the same idea, just top and bottom. So if I would the arrows go through the top boundary? How high do I have to go before the arrows wouldn't go through? Is there a distance I could go where the arrows would never go through? No, the arrows would always go through, right? So there is no top. Is there a bottom? Where's the bottom? What's another word for bottom? So where's the minimum? What did we say the minimum was? From -4. From -4 to positive infinity. Positive infinity means there is no top. So from -4 to positive infinity. The bottom is at -4. The top, there is no top. There was no maximum. We said there was no maximum. So it's just going to keep going forever and ever and ever. All right. All right, so now we're going to do B. If you're getting the hang of this, try it on your own. If not, wait for me. Okay? We don't need phones for this, though. Phones, put those away. That's your one warning. Next time, 10% off the next test. Imagine your last test with 10 points gone. That's not good, right? Your last quiz. So put the phones away, okay? All right, so here we go. Now we got another graph. This one's not a positive graph, it's a negative graph. So the arrows are on the bottom. Okay? So the vertex is going to be at the top. Where is the vertex at? Make the dot. You had a paper too. Make the dot on the paper, and then tell me the address. 3. What's the actual address? Don't just give me the street. I need the whole thing. 30? Okay. That's what it is. Spread it down. 30. Is this guy going to have a maximum or a minimum? Maximum. So minimum, we draw a line through because it doesn't have a minimum on this one. So what's the maximum? It's the same thing as the minimum. It's the y value of the vertex. So the y value comes straight down, and that's 0. Okay. Now, where is that green line that splits it in half? It's easy to see because it always goes through the vertex. So it's right there. Okay. Always goes through the vertex, and it's always going to be vertical. Just remember, it starts out always x equals. Which x number does it go through? 3. Good. Y-intercept. Well, it crosses the y-axis at this dot there. So again, give me directions. How do I get to that orange dot? Is it negative 9, 0, 0, negative 9? 0, negative 9. Always 0 first. Okay. Where does it touch or cross the x-axis? So it's not going to cross the x-axis, right? It's not going to cross. Remember, the x-axis is right here. So it's not going to cross it, but it will touch. Where does it touch the x-axis? 3, 0, right? 3, 0. So can the vertex and the x-intercept be the same? Yeah. They can share. 3, 0. They can share. It's okay. Okay. Increasing. Where is it going uphill? Where is it going downhill? So which arrow do I start at? Left arrow or right arrow? Left arrow. So am I going uphill from the left arrow? Trace. Trace. From the left arrow, am I going uphill or am I going downhill? So if I go up, I stop going up right there. So I go from negative infinity, and where do I stop going up? 3. So from negative infinity to 3, let's write that down. Okay, so if I went up and I stopped there, then I'm coming down. So where did I start coming down and where do I finish going down? Downhill. From where to where? From 3 to positive infinity. Good. Positive. Positive is above water. Where am I above water? Where am I below water? Well, to start, am I above or below? Below, right? I'm below, so let's see. I'm below. Do I ever go above water? No. I don't ever go above water. So I go below water, below, from negative infinity to positive infinity. Below is negative. Where am I above water? None. I never go above water. I'm always below. I come up, but I don't go above water. Domain. Where are the sides going to be? Where can I contain it so it won't get any bigger, grow any wider? What did we say on the last one? Could I contain it on the sides? So it's negative infinity to positive infinity. The range, top to bottom, or bottom to top. Is this one going to have a top or a bottom? So the arrows are on the bottom, right? So how far are those arrows going to go? Forever. So it's not going to have a bottom. Did it have a maximum or minimum? So that means it's going to have a top, not a bottom. So the bottom is going to go on forever, but where's the top going to be? Right there, right? Is that at 3? Y value. What is the Y value I'm at? 0. Good. So from negative infinity to 0. I'll give you a little hint. The range let me see, why did I write it last period? I wrote it better last period. If there's no bottom, it's always going to start negative infinity to the top. If there is no top, it's going to be bottom to positive infinity. Okay? That's for the range. So no bottom means a maximum. No top means a minimum. So that's how you know which one. Do I have a maximum or do I have a minimum? That's just for the range. And remember, the range is the Y values. It's the only one where we look at the Y. Okay, so you're going to do graph C right now on your own. You're going to do graph C on your own. We'll go over it. But if you're sitting there waiting for me, we won't go over it. Try it. There's no penalty if you get them wrong. It's not a test or a quiz. If you get them wrong, big deal. Right? It's practice. It's pre-practice for what we're going to do tomorrow. Okay? Try them. Do the ones that you can. Try it. You can erase it if you get it wrong. Sounds like you guys are kind of getting the idea of it, so try it, and then we'll go over it. So graph C. So this one is a negative, so it's going to have a maximum. The vertex is at the red dot. The red dot is at 2, 1, 2, 1. So I'm going to go put that over here. 2, 1. Okay. Next thing was is that a maximum or a minimum? Well, if it's the top, it's a maximum, right? It's a maximum. So that means it's not going to have a minimum. And what is the maximum going to be? It's the Y value, which is positive 1. Okay. The axis of symmetry always starts x equals. Which x number does it pass through? 2. 2. Y-intercept, where does it cross the y-axis? That's the orange dot. So you got to give me directions on how to get there. It's either going to be -3, 0 or 0, -3. 0 always starts with a 0. Good. Always starts with a 0. 0, -3. Where does it cross the x-axis? At the blue dots. The blue dots, the first one is at 1, 0, and the next one is at 3, 0. So there's 2 of them. 1, 0, 3, 0. Okay. Positive interval are increasing. Where is it going uphill? Well, let me erase this stuff. So we start with the left, the negative infinity, and I'm going up. If I start here, I'm going up. I'm going up, I'm going up until I get to the red dot. So from negative infinity to 2, negative infinity to 2, that's where I'm going uphill. Where am I going downhill? Well, I start at negative or positive 2, so I'm going uphill. Here is where I switch and go downhill. So from 2 to positive infinity. Okay. Where am I above water? Where am I below water? Well, above, only a little bit. You're only above there, you're below the rest. Yellow is above, green is, or sorry, yellow is below, green is above. So from negative infinity, I come up out of the water at 1. So from negative infinity to 1, I'm below water. I'm also below water from 3 to positive infinity. So when am I above water? From 1 to 3. That little part from 1 to 3 is where I come up above water. The domain is going to be negative infinity to positive infinity, just like the last two. This one has no bottom, so it's going to be from negative infinity. Where's the top? At 1. The top was at 1. It had a maximum. Okay. So, all right, tomorrow we'll do some practice.